This video is to help us go through the word problem roulette and just figure out the type of problem and then write our answer in a full sentence. So just as a recap, the types of problems that we are looking at are an equation, system of equations, inequality, or systems of inequalities. When we're looking for the difference, there's two things that we can look for. So the difference between an equation and system of equations, or inequality and system inequality, is the number of totals. Systems of equations have multiple totals, so that helps us figure that piece out. Then the difference between equations and inequalities, inequalities has those key words. So our words like no more than, at least is another big one. Those type of words that tell us that we're dealing with a range, not exactly one number. Equation and systems of equations are dealing with exactly one number. So let's take a look at number one first. Patrick wants to spend no more than $175 on food a week. He spends $115 on groceries per week, and he also likes to eat out at restaurants, spending an average of $18 each time he eats out. What is the maximum number of times that Patrick can go out to eat? When we look at this, the first thing that we want to do is figure out the type of problem. When I look for my number of totals, whether we have multiple totals or we have one total, I see that I have one total. I'm looking to spend $175 per week. That one total means that I'm either down to an equation or an inequality. With this problem, I also see that I have some key words. I see the words no more than, and I see maximum number of times. Those key phrases tell me that I'm dealing with an inequality. So that is our type of problem. Once we figured out that it's an inequality, now we get to write our inequality. The inequality that we're going to write has our total on one side and what gets us to our total on the other side. Our total is 175, and what gets us to our total is our $115 for groceries. Yes, it says each week, but 175 is also talking about each week, so that's not relevant. The part that is important is that we see this word each with our $18. When we see the word each or per, that tells us that that's going to have our variable. So our groceries and the amount that we spend going out to eat is no more than 175. If it's no more than 175, that means it's less than or equal to. We can spend less, we can do exactly 175, but we can't do any more. When we solve this, we get a decimal. So we get that x is less than or equal to 3.33 repeating. Remember, with our word problems, we have to round appropriately. We can't have 0.333 of a time. It's not possible. So since we don't have enough to get to 4 times, when we round this, we are going to say the maximum number is 3 times. Again, we're writing our answer as a full sentence. So the maximum number of times he can go out to eat is 3. Looking at number 2, Jared brought 48 cupcakes to school. At school, he gave 3 cupcakes to each student in his class, and he has 6 cupcakes remaining. How many students are in Jared's class? When we look at this one, we see again that we have one total, so that tells me it's either an equation or an inequality. With this, we don't have any of those key words that come with our inequalities, and we're dealing with exactly 48 cupcakes. If it's exactly 48 cupcakes, then that tells me that this is going to be an equation. Now we're going to write our equation. Again, total is on one side, that's our 48 cupcakes. And to figure out our number of cupcakes, we know we're going to have 6 left over, and then we gave 3 to each person in our class. When we see each, that tells us we're getting the variable. So we can say 3c. You can pick any variable, it doesn't matter. When we solve this one for c, we get c equals 14. Again, interpreting this problem means that there are 14 people in Jared's class. Number 3. Miss I is giving you a test worth 100 points containing 40 questions. There are 2-point and 4-point questions on the test. How many 2-point questions are there? When we're deciding the type of problem, this time I see that I have 2 different totals. We have 100 points and we have 40 questions. That automatically tells me that I'm between a system of equation or system of inequality. Since we have exactly 100 points and exactly 40 questions, this is going to be an example of systems of equations. When we write systems of equations, remember that means that we're going to write 2 different equations. The 2 different equations are going to come from our number of points for one equation and our number of questions for the other. It's important to define our variables. That way we can make sure we're answering the question fully. X, I'm going to say, are the number of 2-point questions. And Y is going to stand for the number of 4-point questions. Writing out my 2 equations now, we get the number of questions, so X and Y, is equal to 40. For my points, each X question, each 2-point question is worth 2 points, and each 4-point question is worth 4 points, and that equals 100 points total. From here, what we need to do is we need to plug it into Desmos, and we need to see where those points intersect. When we figure out where they intersect, we are going to be looking for that ordered pair. When we graph that, our ordered pair, the point of intersection, is 30, 10. This is where defining our variables is really important because this question is just asking for the number of 2-point questions. When we defined our variables, our 2-point questions were our X. So to answer this question, all we need is that X value. So our full answer is going to be there are 30 2-point questions. Going now to number 4. Number 4 is a little bit trickier. We have Larry and Barry, who are brothers. Together, they worked for 85 minutes on their chores. Barry worked 5 minutes less than twice the amount of time that Larry worked. How long did each brother work on their chores? Looking at this, a lot of people are going to at first glance say that this is a system, but it's not. The reason it's not is we only have one total. We're just talking about 85 minutes. Both brothers are included in that 85 minutes. Since it's exactly 85 minutes, this tells me that this problem is going to be an equation. To write this equation, we need to write things in terms of Larry and Barry. Larry worked some unknown amount of time. They never told us how much Larry worked. So we're going to call that our X. For Barry, they described an expression to us. They said that Barry worked 5 minutes less than twice the amount of time that Larry did. When we write that, remember that when we see less than or more than, the first thing goes second. So we're really subtracting 5 from 2x because we have twice the time of Larry. Both of the brothers together are totaling 85. So that means we have x plus 2x minus 5 equals 85 as our equation. When we solve, we're going to get that x equals 30. With this, it's important that we figure out both of our brothers. X stood for the time that Larry worked, so we can automatically say that Larry worked 30 minutes. To figure out the time that Barry worked, we're going to take our 30 and we're going to plug it into our expression. So for Barry, to figure out our total time, we have to do 2 times 30 minus 5. 2 times 30 gives us 60. 60 minus 5 gives us 55. So that means that Barry worked 55 minutes. Number 5, Samantha made goodie bags for Valentine's Day. They were filled with chocolate and candy. The cost of chocolate was $2.50 per pound, and the cost of candy was $3 per pound. Samantha bought 15 pounds of chocolate and candy for a total of $40. How many pounds of candy were purchased? This is another example where we have two different totals. We have our number of pounds of chocolate and candy, and we have our amount of money that we're spending on it. Since we have two different totals and we're spending exactly that much, we are going to have a system of equations. To write out our equations, again, we're going to define those variables. I'm going to say that X stands for our chocolate, and then Y is going to stand for our candy. Writing our two equations, one is going to be our amount of money and the other is going to be our amount. So for our amount, we would have X plus Y equals 15 pounds. For our money, we have $2.50 for each chocolate, and we have $3 for each candy to total $40. Again, with those equations, what we're going to do is we're going to plug them into Desmos and see where they intersect. The point where they intersect is 10, 5. For this problem, though, we just want to know the amount of pounds of candy. Candy, I said, was my Y, so when I look at my ordered pair, 5 is the number that I want to use. So I'm going to say there are 5 pounds of candy. Last problem on this page is Emily wants to earn at least $120. She earns $10 an hour at Target and $15 an hour teaching piano. She does not want to work more than 20 hours total. What are the possible hours that Emily needs to work at Target and teach piano? This problem is an example of a system of inequalities. What tells me that this is a system is I have two different totals. There we go. I have two different totals. So we have 120 and we have 20 hours. We need to define our variables. So we have X as Target and we have Y as piano. I also know it's inequality because I see my keywords at least and I see the words no more than. When we do this, we are going to plug in our equations into Desmos. So we have our two inequalities. Remember, at least is the greater than or equal to sign because we want at least that much or more. Remember in class that we talked about our answers are not where they intersect, but anything in our overlapped part. For this problem too, we also talked about how both things have to be positive. So all of our answers are in this little trapezoid section where both the X and the Y are positive. So just as an example, I'm going to pick this point right here that's 12, 2.